Good afternoon, everyone. Uh, Today we'll discuss about the basic difference between plant use factor and plant capacity factor. So, I've designed a problem for you to make you understand what is the basic difference between the plant use factor and plant capacity factor. So, in this problem, the generation schedule of a power plant is provided for timing for different time of a day. So from 12 midnight to 6 a.m., the load demand is 500 megawatt. All the load demands are provided in terms of megawatt. So this is the time duration from 12 midnight to 6 a.m. The power demand or load demand is 500 megawatt. From 6 a.m. to 8 a.m. it is 1200 megawatt. From 8 to 12 noon it is 1000 megawatt. From 12 noon to 4 p.m. it is 800 megawatt. From 4 p.m. to 6 p.m. it is 1000 megawatt. From 6 p.m. to 10 p.m. it is 1600 megawatt. From 10 p.m. to 12 midnight it is 600 megawatt. So basically the load demand on the power plant is varying. Okay, so from this load information, if we plot the load curve, then we'll get the maximum demand on the power plant is 1600 megawatt and the minimum demand on the power plant is 500 megawatt. So considering the maximum and minimum demand as we have already discussed in the previous class, we can choose the different units and the capacity of different units. So from the load information, I have selected different units. So first unit of 500 megawatt. This is according to my consideration. So I've considered one unit of 500 megawatt. I've considered another unit of 500 megawatt, and the third unit of 1000 megawatt, fourth unit of 1000 megawatt. Okay. So basically for this power plant, I have considered four different units, two unit of 500 megawatt each and two unit of 1000 megawatt each. But the load demand on the power plant is 1600 megawatt. So the next 1000 megawatt I have considered for the maintenance purpose. So during the period of maintenance of this 1000 megawatt unit, I can run this unit, or during the maintenance of these two units, 500 megawatt unit, I can run this single unit. So this can be considered as the backup unit for the power plant. So basically the requirement of the plant is 2000 megawatt, and I've considered one more unit for the maintenance period. So the total capacity of the power plant is now almost 3000 megawatt. Okay, 1000 plus 1000 plus 500 plus 500, that will be 3000 megawatt. Now the reserve capacity, what is the formula for reserve capacity for the power plant? The reserve capacity for the power plant is nothing but the total plant capacity minus the maximum demand. Here the plant capacity is 3000 megawatt, but the maximum demand on the power plant is 1600 megawatt. So reserve capacity can be calculated as 3000 minus 1600 will be your 1400 megawatt. Now, how can we calculate? Okay. Now, how can we calculate the total energy generated? This one, the total energy generated per day. So the total energy generated can be calculated from the load curve or directly from the load information. So the total energy generated in a day can be calculated as the hours of operation into power demand. So 12 to 6 will be your 6 hours into 500 megawatt. So 500 into 6 plus similarly 1200 into 2 plus 1000 plus 1000 into 4, this one, plus 800 into 4 plus again 1000 into 2, then 1600 into 2. Okay, 1600 sorry 1600 into 4 plus 600 into 2. So total energy generated in a day is equal to 1600 16800 megawatt hour. Okay, this one. The total energy generated per day is equal to 16,800 megawatt hour. Now, this is the actual energy generated in a day. According to the load demand, the actual energy generated in a day is 16,800 megawatt hour. Megawatt hour is the unit of energy. Okay. Power load demand into hours of operation. Now, how to calculate the power plant capacity or the plant capacity factor from the available data. So the formula for plant capacity factor is nothing but the total energy generated or actual energy generated upon the plant capacity into hours of operation. So as one day information is provided to us, so how to calculate the plant capacity factor? Here the actual energy generated is nothing but 16,800 megawatt hour, and plant capacity is how much? 3,000 megawatt. So plant capacity factor can be calculated as actual energy generated, that is nothing but your 16,800 megawatt hour divided by your plant capacity, that is your 3,000 megawatt, into hours of operation. The total hours of operation will be 24. Okay, so 16,800 megawatt hour divided by 3,000 megawatt into 24 hours. Okay, so the plant capacity factor will be 0.233. Okay, that means 23.3%. What is the meaning of this? The meaning of plant capacity factor is that we are using only 23% or 23.3% of the total plant capacity for generating power for that day. So in that day, we have utilized only 23.3% of the total power plant capacity. Now the second factor, that is your plant use factor. How to calculate the plant use factor? So plant use factor can be calculated as the formula. It is given the same in the book, but it is totally different. Okay. So plant use factor can be calculated as actual energy generated in a day or in a particular time period divided by total energy could have been generated. That means for that day you are generating only 16,800 megawatt hour. Okay, but during the same time period, how much power you can generate using the same units? That is the meaning of plant use factor. Because for supplying this from 6 to 8 a.m., you have your total demand is 1200 megawatt. But to supply 1200 megawatt, you have to run one unit of 1000 megawatt and one unit of 1500 megawatt. So actual generation will be 1200 megawatt, but you could generate at that time will be 1500 megawatt. Okay, you could have generate 1500 megawatt at the time period. So how to calculate plant use factor? So to make you understand this, I have made one table. So depending on the time period and actual load demand and the actual operating unit. So this is the time period that I have provided in the first table, and this one is the load demand, second column. Now actual load demand is 500, so I have to run 500 unit, 500 megawatt unit. So the actual power generated is 500, and expected or could be generated will be your 500. Then from 6 to 8 a.m. my demand is 1200 megawatt. But to supply 1200 megawatt, I have to run two units of one unit of 500 megawatt and another unit of 500 megawatt. So the actual energy or actual unit operated during the time period will be 1500 megawatt capacity. Okay, so again, for 1000 megawatt, that is from 8 a.m. to 12 noon, 1000 megawatt demand, I have to run only one unit. So I could have generated at that time 1000 megawatt. Then for 12 to 4, the demand is 800 megawatt, but at that time I have to run 1000 megawatt unit. Okay, so maximum I can generate up to 1000 megawatt, but my demand is 800 megawatt, so that's why I have generated only 800 megawatt. From 6 to 8 p.m., my demand is 1000 megawatt, and the actual unit operation will be 1000 megawatt capacity. Now from 6 to 10 p.m., the actual demand is 1600 megawatt, but I have to run two units of 1000 megawatt, or I have to run three units of 500, 500, and 1000 megawatt. So maximum capacity during that period, the maximum running capacity of that period will be 2000 megawatt. 2000 megawatt. Again, from 10 p.m. to 12 midnight, the actual demand is 600 megawatt, but I have to run 1000 megawatt unit. Okay, so the total energy generated, the actual energy generated during the day will be 16,800 megawatt hour, but that energy could be generated or energy could have been generated during the time period will be 500, this one 500 into 6, this is the hour of operation. Okay, 500 into 6, then again 1500, because the total units of operation during the time period will be two unit, one of 1000 and second one is of 500 megawatt. So although my demand is 1200 megawatt, I could have been generated 1500 megawatt during the time period. So the energy could have been generated during the time period will be 1500 into this one, 1500 into 2, again same 1000 into 2 plus 1000 into 4, then 1000 into 2, this one, then 2000. Here the demand is although 1600, but I run at the time three units of 2000 megawatt capacity. Okay, So the actual energy could have been generated will be 2000 into this one, 2000 into 4. The last one will be actual demand is 1600, but I have run 1000 unit capacity. So at that time, power could have been generated will be 1000 into 2. So the actual energy generated during the day will be 16,800 megawatt hour, and the actual energy or the total energy could have been generated will be 26,000 megawatt hour. So how to calculate plant use factor? 16,800 megawatt hour divided by 26,000 megawatt hour. So the factor will be 0.646. That means I have utilized 64.6% of plant of the unit capacity. So during the time period, I have used only 64.6% capacity of the units. Okay, the running units, not the plant capacity. I have used only 64.6% capacity of the operating units during the time period. Okay, this is the basic difference between plant use factor and plant capacity factor.